Hello, and welcome to Lesson 3.1 and 3.2. So first off, we're going to start with just looking at the title for Chapter 3, which is Solving Linear Equations. And the reason that this is important to understand is all the equations that we're looking at in this chapter, being linear equations, means that they can be graphed as a line or represented as a line. So everything that we're looking at is linear in this chapter. Later, we will start to look at different types of equations, but for now, we're only looking at ones that can be represented by lines. So 3.1 and 3.2 are solving one-step equations for a given variable or for a unknown variable. So in this case, we're looking at our four main operations: addition, subtraction, multiplication, and division. So, and instead of splitting into two videos, we're just going to take care of both lessons 3.1 and 3.2 in this video. And then you'll see that this note sheet also contains lesson 3.3, solving multi-step equations. It only made sense to keep our initial notes on solving equations in the same place. So we will continue on these sheets with lesson 3.3 in our next video. So our goal for today is simply to solve one-step equations. We'll come back to the multi-step, and we're solving them for one variable. So in order to solve any equation, you need to first understand the concept of inverse operations. And inverse operations are operations that undo each other. So addition and subtraction are inverse operations. Multiplication and division are inverse operations. They undo each other. Or a second power or something squared and the square root are inverse operations. But again, today we're just looking at your two main inverse operations, which are addition and subtraction, and then multiplication and division. So inverse operations help us in that process of isolating the variable in an equation. And to isolate a variable simply means to get it alone or solve for its value. So how do we isolate a variable? Well, we want to use inverse operations, which means we're working the order of operations backward or in reverse. So I always teach, again, the order of operations as GEMDAS, the G being grouping symbols, so parentheses, brackets, etc. The E being exponents or powers, M multiplication, D division, A addition, S subtraction. So now instead of GEMDAS, we have SADMAG. Not necessarily that catchy, but that's an easy way to remember it. So we are doing this, working it left to right. So the first thing we want to undo are addition or subtraction. And the way we do that is with their inverse. So if we have subtraction, we undo it with addition. If we have addition, we undo it with subtraction. And then if we have division, we undo it with the inverse, which is multiplication. And if you have multiplication, you undo it with the inverse, which is division. And then in later lessons, we'll worry more about the grouping symbol and exponent components. So let's look at our first few examples with one-step equations. Now you'll notice on all my examples, I draw a vertical line segment through the original equal sign. That is just to keep myself organized. Because what allows inverse operations to work in these equations, and we'll get more into these property names later, and you'll have to come back to them in geometry, but they are known as the algebraic properties of equality. And those properties of equality, simply put, allow us to do the same operation on both sides of the equal sign, and the equation is still considered equal. So hence the name, properties of equality. And there's different ones for the different operations. So there's an addition property of equality, subtraction property of equality, multiplication, and division. And those are what are allowing us to solve for the variables or to isolate our variables with inverse operations. So now in example A, we have 9 plus x equals 4. And again, you always want to think, how do you get the variable alone? So if it's 9 plus x, to undo the addition of 9, or to get the positive 9 back to 0, so we'd have x alone, you subtract 9 from the left-hand side and subtract 9 from the right-hand side of the equals, giving us x equals 5. In B, x minus 15 equals 6, so the inverse operation of subtraction would be addition. So we add 15 on both sides of the equal sign, giving us x plus 0 on the left, so just x, and x equals 6 plus 15, which is 21. In C, we have to deal with some integers or negative whole numbers. So we have a negative 12 equals 7 plus b. So again, we want to isolate the variable, which is b. So it's b plus 7. So inverse operation, subtract 7 from each side. Negative 12 minus 7 gives us a negative 19. The positive and negative 7 here cancel, so b equals negative 19. Now examples D, E, and F. So in D, we have y plus 1/2 equals negative 3/4. Doesn't matter that we're dealing with fractions, we can still use our inverse operations. So subtract 1/2 from each side of the equal sign. And again, that would be the subtraction property of equality that allows us to do that. So we would have the positive 1/2 and negative 1/2 on the left that cancel, leaving us with y, and then a negative 3/4 minus 1/2. So again, to add or subtract fractions, we need a common denominator. So our common denominator in this case could be 4. So it would become a negative 3/4 minus a 2/4. So negative 3 minus 2 on top is a negative 5 over 4, or a negative 1 and 1/4 if you want to write it as a mixed number. Unless I specifically tell you to simplify, I am fine with improper fractions that are equivalent to the mixed number. In E, we have 15 multiplied by n equals a negative 60. So remember, any number next to a variable means it's multiplication. So this is 15n, or 15 multiplied by n. So our inverse operation is division. So to get n alone, we want to be left with 1n. So we would divide both sides of the equals by 15. 15n divided by 15 is just n. Negative 60 divided by 15 is a negative 4. So n equals negative 4. F, we have a negative 9.6 equal to a negative 1.2 multiplied by x. So we want to undo the multiplication with division. So we would divide both sides by the negative 1.2. Then negative 9.6 divided by negative 1.2 would give us 8. And a negative divided by a negative gives us a positive, so x would equal 8. And then our last 3 examples for our first 2 lessons. We'll get into the 2-step equations in lesson 3.3. So we'll look at g, h, and I. In g, we have x over 3 equals 11. So x divided by 3 equals 11. So to get back to just 1x, or get x alone, we need to undo the division of 3. So we would multiply both sides of the equals. So the multiplication property of equality, multiply both sides of the equal sign by 3. So the 3 on top and bottom would cancel. We're left with x equals 33. In h, we have a negative d over 4 equals a negative 6. So again, if we have a negative in front of the fraction, basically we can decide if that negative is attached to the top or the bottom. So to make my life easy, I want to be left with a positive d, so I'm going to multiply each side by a negative 4. So I'm going to get rid of both the negative and the 4 on bottom from the d divided by 4 to then solve for d. So multiply both sides by the negative 4. So our left-hand side is d, and the right-hand side, negative 6 multiplied by negative 4, equaling a positive 24. And then our last example for today, we have I here, a negative 1/3 y equals 5 2/3. So you can think of this as a negative 1/3 multiplied by y, or multiplying this by a negative 1/3 would be the same thing as a negative y over 3, or a y over negative 3. So in this case, a negative 1/3 y, same thing as negative y over 3. On the right-hand side, because I know I'll be dealing with multiplication to undo my division, I want to make this mixed number into an improper fraction. And again, in order to do that, you take the whole number out in front, multiply it by the denominator, and add it to the numerator. So 5 multiplied by 3 is 15, plus the 2 on top would give us 17. So 17 over the denominator of 3. Then we're multiplying both sides by 3 to get rid of that denominator of 3. And we would be left with the opposite of y, or a negative y, equals 17. Then to get rid of this negative y, we simply bring it over to the other side. So we're changing the sign on the right-hand side. And what allows us to do that, technically what we're doing, is we are dividing each side by a negative 1, which gets rid of the negative on the left and makes it appear on the right. So if an opposite of y is 17, then y is a negative 17. So as you go through the problems for today, be careful with some of the negative signs and make sure you follow your rules with integers. So if you're multiplying or dividing, 2 of the same sign, so 2 positives or 2 negatives, will always give you a positive value. 1 of each sign, so 1 negative, 1 positive, when multiplying or dividing, will always give you a negative value. And then just remember that concept of inverse operations and undoing subtraction with addition, addition with subtraction, division with multiplication, and multiplication with division.